You know, we see these large language models do just incredible things, right? Solving problems that would make most of our heads spin. But what if I told you there's a hidden cost behind all that genius? A really, really big one. Because the way these models think can be unbelievably wasteful.
It's a weird paradox, isn't it? An AI can produce a perfect solution to some crazy complex problem, but to get that one right answer, it might have had to churn through hundreds, even thousands of wrong answers first. So in this explainer, we're going to dig into why that happens, and then explore this amazingly elegant solution that teaches AI to think smarter, not harder.
All right, so let's get into it. What exactly is this thinking problem? Well, it all starts with a very popular technique people use to make AI models more accurate. It's effective for sure, but it's a total brute force method that comes with a seriously heavy price tag.
So this technique is called self-consistency. The idea is actually dead simple. You ask the AI a question, but instead of just one answer, you have it generate, say, 100 different ways of thinking about it. All these different thought paths. Then it just looks at all the final answers and holds a vote. Whichever answer pops up the most wins. It's literally democracy for an AI's thoughts.
And this right here, this gets to the core of the whole issue. On the one hand, you have the brute force approach. Just generate a ton of paths and hope the right answer gets enough votes. But the ideal, the dream, is on the other side. A single, clean, efficient path right to the correct answer. The fundamental flaw with the brute force way is that it treats every single one of those thought paths as equal, no matter how brilliant or how confused it is.
So what's the actual cost of all this? Well, the researchers behind the new method we're talking about, DeepConf, they ran the numbers. To get just a modest bump in accuracy on a hard math problem set, one model had to generate over 100 million extra tokens. 100 million. That is a staggering amount of wasted computation, all just to filter out the bad ideas. Okay, but this is where the story gets really, really interesting. Researchers from Meta AI and UCSD came up with a breakthrough idea. They thought, instead of letting the model think all over the place and then cleaning up the mess, what if we could just listen in while it's thinking? This is it. This is the simple but powerful question at the heart of their method, DeepConf. Forget generating hundreds of complete thoughts. What if the model itself could just raise a little flag and say, hey, hold on, I'm kind of guessing at this part. Or on the flip side, yep, I am absolutely certain this is the way forward. And it turns out that signal already exists inside the model. It's called token confidence. See, every time an LLM generates the next word or token in a sentence, it has an internal probability score. High confidence means the model is pretty sure about its choice, but low confidence, that's a sign it's getting uncertain. It's basically guessing. And DeepConf is all about learning how to listen to that signal.
This quote from the research paper just sums it all up perfectly. The old way, that majority vote system, it completely ignores quality. A brilliant line of reasoning gets the exact same single vote as a path that's just full of confused nonsense. DeepConf changes the game by using the model's own confidence as a direct measure of quality.
Okay, so how does this smart filter actually work? Well, DeepConf operates in two main ways, which the researchers call offline and online thinking. The first method is offline thinking. With this one, you still let the model generate all its different thought paths. But instead of a simple vote, you give more weight to the answers that came from high-confidence paths. The second method, online thinking, is even smarter. Here, you monitor the confidence as the thought is happening. If the confidence drops too low, you just stop the process right there, which saves a huge amount of time and energy. The researchers also figured out that just averaging the confidence over a whole thought wasn't quite enough. So they developed these more sophisticated ways of listening. For instance, tail confidence just focuses on the final steps of the reasoning, since that's where mistakes often happen. And lowest group confidence is designed to find the single weakest link in the chain, that one moment of deep uncertainty that usually comes right before a mistake. So the online method is pretty straightforward. The model generates a chunk of text, and DeepConf checks its confidence score. If the score is high, great, it keeps going. But if it suddenly plummets below a certain point, it's cut off immediately. You can think of it like an editor telling a writer to scrap a paragraph the moment they sense hesitation, instead of waiting for them to finish the whole flawed chapter. So the big question, does it actually work? This is the moment of truth. Let's take a look at the results because they are, well, they're nothing short of dramatic. First, let's talk efficiency. The savings are just massive. On this really challenging math benchmark, AMI 2025, DeepConf cut the number of tokens a model needed to generate by up to 84.7%. That is not a small improvement. It is a fundamental shift in how much compute you need.
But here's the real kicker. You might think that by generating less, you'd have to sacrifice some accuracy, right? Well, the opposite happened. By filtering out all of the low-confidence junk reasoning, DeepConf actually improved the final accuracy. It's getting better answers while doing way, way less work.
So how much better are we talking? With DeepConf, a really powerful model called GPT-OS 120B achieved 99.9% accuracy on that same math benchmark. It basically aced the test, getting nearly every single question right, a solid improvement over the 97% it got with the standard, more wasteful method.
So what does this all mean for the future of AI? Well, DeepConf isn't just some clever trick. It really represents a much more sustainable and frankly reliable way for AI to think.
To sum it all up, DeepConf delivers a triple win. It makes AI more efficient by cutting out all the waste from brute force thinking. It makes AI more accurate by focusing only on the high-quality lines of reasoning. And maybe most importantly, it makes AI more reliable by giving us a way to check the quality of its thinking using its own internal signals.
And that leaves us with a fascinating final thought. We've just looked at a method that lets an AI tell us when it's uncertain, when it's confident, and when it's just guessing. This opens up a whole new world for trust and for how we work with these systems. So I'll leave you with this question. If an AI finally knows its own limits, what new critical tasks can we finally start to trust it with?